Welcome everybody to this sixth webinar of the Community of Oceania Geospatial Water Resource Workgroup. And tonight we will be talking about water and artificial intelligence for the Pacific Islands. And I'm glad actually to introduce Bertrand a bit later, Bertrand Lacroix from New Caledonia, Aqualone, which will be
Good
our
everyone.
second speaker. So does that work? Up. So as a reminder, our Community of Oceania Geospatial Water Resource Workgroup is co-animated by Nicolas from SPC based in Fiji, and he's sorry, but he has another meeting at the moment, so he will probably join, but kind of not all the time, so he doesn't know yet if he will be able to join us all the time. And animated by myself, Pearl Winchester. I'm originally from New Caledonia. I'm a tropical island water specialist, IT engineer and GIS and public policy expert now. And I'm currently in France to finish my studies in leadership for sustainability. Just a quick reminder, what is the Community of Oceania Geospatial Water Resource Workgroup? I know many of you already know about it, and if you could please put your name and role and the country in the chat so we know where you're coming from, please. So the Community of Oceania Geospatial Water Resource Workgroup aims to share information and knowledge for the benefits of our Pacific Islands around water resources in Oceania and around geospatial, which is GIS, satellite, etc. And so you can see some of the topics, but it's not exhaustive list, and you can join us on LinkedIn. I will share the link just a bit later in the chat, and everyone is welcome, public and private sector alike. I am going to leave the floor to Bertrand to introduce himself. Bertrand, if you could please, introduce yourself.
Yep, good everyone. So I'm Bertrand Lacroix. I'm based in New Caledonia. I'm the CEO of a startup called Aqualone. And this startup aimed to reduce by 50% irrigation water consumption. We have deployed the technology in New Caledonia and now starting to deploy it within the Pacific Islands, starting by French Polynesia. So that will be the topic on my side for today.
Thank you, Bertrand. Thank you for accepting to be a speaker today. And so we will start straight away with actually me speaking about water and artificial intelligence. I prepared a quick scientific literature review and technology watch on what's going on between artificial intelligence and water and artificial intelligence and GIS. So I will try to not be too long, but just give you a few inputs about what is AI and how we can use it for the Pacific. So first of all, what is AI? I know you might have heard about it, but artificial intelligence is the capability of computational systems, so computers, to perform tasks that are typically associated with human intelligence. So you have computers and human that are kind of how to say, approached. And artificial intelligence is giving learning, reasoning, problem solving, perception, and decision-making solutions to us. And you can see in this graph here, in this image, that you have different layers inside artificial intelligence, especially machine learning, which is the ability for computers to learn from experience or data without human programming. You have deep learning, which mimics the human brain using artificial neural networks, such as transformer, to allow computers to perform complex tasks. And you have the generative AI, which is applications that can generate new text or images, everything based on pre-trained databases. If we start from the top, the United Nations wrote a recommendation on the ethics of artificial intelligence in 2021. And so this recommendation is that member states and all other stakeholders should respect, promote, and protect the ethical values, principles, and standards regarding AI that are identified in this recommendation and should take all feasible steps to give effect to its policy recommendations. And these values are here. Everything seems pretty straightforward, but I think it's important to say it, to have respect, protection, and promotion of human rights, environment and ecosystem flourishing, ensuring diversity and inclusiveness, and living in peaceful, just, and interconnected societies. And this recommendation is based on some principles. I won't read them all, but you have safety and security, sustainability, right to privacy and data protection, among others. And I do think that this is our role to make sure that these values and principles are implemented and respected in our islands, to make sure that AI is used in a safe and ethical way. Along with this recommendation, the United Nations created a AI readiness assessment methodology in 2023. So I will share the links in the chat a bit later, but just so you know, this is a tool with some indicators to help governments and countries understand where they stand on the implementation of AI. And it brings me to the next slides, where in the Pacific region, we actually have an Artificial Intelligence Asia Pacific Institute that has been created. It's a global non-profit organization, and it's based in Singapore and Boston. And they actually have worked on this AI assessment. And in one of their reports, you can actually find the report, The Status of AI in the Pacific Islands, which is saying that today, in 2024, it was published in 2024, there is no currently active AI strategy in the 16 Pacific Islands and countries that were assessed. The AI readiness remains weak. The potential important with steps taken to initiate projects, payment systems to medical record software are actually available. There is no systematic and comprehensive government-led AI governance in any of the 16 islands. The first effort should be directed towards broader digital and ICT, which means information and communication technologies initiatives. Data protection and privacy laws are limited in the region, so this is also something we need to work on. And significant progress are needed to support emerging technologies in our countries. They share a few AI solutions that are already implemented in Asia or Pacific, for example, Tractable in Fiji. And I will share the links in the chat a bit later. I also wanted to share with you a few, a few results coming from scientific articles. So the first one is ecological restoration of watersheds and AI. So it's from Fernando Morante Carvalho and others, and it was published last year. And so what we learned with this article is that right now it's China and the United States that are the most outstanding contributors around ecological restoration of watersheds and AI. They are saying that water scarcity affects 40% of the world's population, and we are actually consuming more water than what we actually have in supply. And 51 countries are predicted to suffer high levels of water stress by 2050. And so they are giving a few examples and strategies about how AI is applied to ecological restoration. And they also, emphasis on the fact that the knowledge of water quality is really mandatory with some parameters that are vital indicators of the health of the water bodies we have to manage. And so most of the time, what they have seen in this systematic review is that today AI is used for control radiation to minimize the negative impacts on, for example, peatlands. It is used for water treatment. It is used for cleanup of contaminated sites to identify the sources of contaminations, for example, and to find some remediation scenarios. It is also used for groundwater to have some dynamic decision using pumping rates. So they need the data to be able to do the simulations. This is something very important. And also they have been using machine learning, which is another AI system kind of, to use it for degraded topsoil, which is in forest and watersheds, to kind of predict how the restoration measure will be effective, and also for cleanup of contaminated sites. These are a few examples of how AI has been used in ecological restoration for watersheds. Another article is more about integrated water resource management and AI. And actually, with this article, what we can see is that today the AI models are used mostly here with GIS and satellite images to try to create with the weather forecast some agronomics AI models to try to predict or forecast what the water demand will be to make the best decision making here for the public policies and the decision maker. So most of the time, what they have seen is that the agricultural models that use AI are actually using some remote sensing data coming from Sentinel and Copernicus. And yes, and so this is because most of the time they had to try to find some solutions to conflicts between some irrigation rights that were already established and actual irrigation requirements where the water supplies was lower than what was actually pumped. Another example, but it's kind of getting back to what we were saying about how AI can help in agricultural water. And Bertrand Lacroix from Aqualon is going to tell us more about it later. But just so you know, this article has been focusing on irrigation management, fertigation management, and soil moisture predictions, and how AI with some diverse algorithm can actually help with IoT, for example, and big data techniques. I just wanted to show you here, yes, sorry. Here, this article is saying that the AI models that are most commonly used, are the random forest and the neural network and the decision support. And so I just wanted to show you exactly what is behind it. And so random forest, before telling you about random forest, I just wanted to show you what is the decision tree or decision support. It's you have a first question, and depending on the answer, let's say, do I want to go surfing? Yes or no. And depending on the answer, then another question is opening up. And so the computer starts from one question to another through the answers. Random forest is actually using these decision trees, but way more decision trees together, which is why we have a forest. We go from trees to forest, and they use it randomly with some special algorithm to try to get the best answers. The other model that is very common also is the neural network, where you have input layers. It's sending signals to many hidden layers. This one is a simple one, but you can have actually 1, 2, 3, 4 hidden layers where you can see that the weakness or the strength between the first input layers and the second layer is different. And with mathematical algorithm and the same way, they end up with one output layer using the connection between the neurons. Now I wanted to quickly show you a few tools that are available today when we say AI for GIS. So the first one is TerraMind. It's been created by ESA and IBM, and it's been released just last month, so it's fairly new. And so you will find the articles here, and the model is fully available on Hugging Face. Sorry, there's a U missing here, which is the open source AI repository. And so just so you understand, this model uses many entry data and can help you create whatever you need, because as it's new, how to say, the different uses that can be output from this model are everybody's ready to create it. You can participate and create some new ideas on how you can use this model to do whatever your projects need to create some decision-making solutions. So you can definitely download it and use it. It's completely available. Also, if you are using S3, they have implemented GeoAI directly into ArcGIS Pro or ArcGIS Enterprise. And so what you need to do is to download the deep learning framework from GitHub to add it to S3. And it can help you, for example, these are examples, but extract pictures from imagery and LiDAR, or it can help you find patterns and clusters or detect anomalies, for example. If you are a QGIS user, they created the QA AI Assistant, which is a plugin. It's a chatbot, AI chatbot that is installed in QGIS, but you do need to subscribe. I think it's $90 a month, and it can help you create some SQL query from natural language or edit symbology straight away, for example. What I wanted to say to finish is that you must know that AI is very thirsty. We talk about water, and so some researchers show that for around 20 prompts in a Gen AI application like ChatGPT, it uses half a liter of water. And a new article that has been published a few months ago is actually showing that in a few years, 2027, global AI will consume up to 6 billion of cubic meters of fresh water annually. And just so you can compare, the water consumption in Fiji is 222,000 cubic meters. So when you actually create a prompt, just make sure that you really need it, because it's hiding some water usage that we don't see when we're actually using AI. If you wish to go further, I also saw that there's a GeoGPT website with a demo and some other webinars or some other water articles, and I will share everything in the chat. And so to conclude, my tips and best practices around AI today is the first one is don't be afraid of AI. The second one is learn how to create adapted prompts that will help you perform the task you need the most efficiently. So don't hesitate to try them again, change a few words. Another one, of course, is don't blindly trust AI. You must check and double check the results, because depending on the database your AI has been taught, you might and you will have some biases, or you will have some wrong answers. It's sure. And last one, as I said just before, don't forget that AI has an impact on our natural resources. Please use it wisely. I don't know if you have any questions so far. You can type them in the chat or let me see. I have seen the thing saying that she can't see the chat. Where is this? Hop. Tac. All right. Normally, I don't know where's the. Normally, everybody has access to the chat, so I don't know how come it's not working. Tout le monde. Tout le monde. Ah, there it is. Is it working now, Aude? I'm sorry. You should have access to the chat. Thank you, Rua. Sorry, I thought it was. So, do you have any questions? Everything was clear. You have no questions? I guess. All right. Perfect. Bertrand, you're all blurry and you're upside down.
I'm upside down. Okay, is it any better this way?
Yeah, it's better that way. And you're not blurry anymore. We can see you.
You cannot see me properly.
No, it's all good. Now it's good. And so
Okay.
well, I guess I'm gonna leave the floor to you if I'm correct. Oh no, no.
Okay.
Before you actually talk, I have a small introduction with our participants, our audience. So I'm gonna share the links. Oops, sorry. I'm gonna share the link if I can. Oh no, it's not working. Up. Tac. Up, up. Up. But you can actually use the QR code. It's working. Up. But if you go on that link here, up, you can just answer the two questions that are created. The first one is, have you already used AI for your work? And what for? What did you do with AI when you used it? If you could please answer. Normally it's open. Yes. And normally, yes, exactly. Normally you have access to the questions and you can type some words for the second question. It's going to be a word clouds that we will have at the end. So far I have 4 answers. So thank you for answering. And what we can actually do is, Bertrand, I will leave to you to start your presentation, and I will show the results from the interaction here at the end. Is that okay?
Perfect.
Allez, all right.
Okay.
Alors, tac. Up, so up. Go for Bertrand. Let's go.
Very good. Good morning, everyone. So I'm representing Aqualone, which is a New Caledonian startup company specialized in irrigation. So the challenge that Aqualone is addressing is water for a sustainable future, knowing that our target is to reduce at least by 50% water consumption for irrigation using IoT technology and also using data management in order to provide key performance indicators to the operation team as well as to the governments in order for them to have better control of what's going on in terms of water saving. Why? Because the key problem today is 75% of the overall freshwater consumption is used by irrigation. So if there is an area where we can and we have to reduce water consumption and use it more wisely, it's on the irrigation side. And this is the decision that Aquadon has been made, addressing the scarcity of water for the coming years, as Pearl was mentioning. Our technology is going to be organized in 4 different compartments. The first one is LoRa technology, which is a radio system that allow a possible with any IoT objects over a range of 2 kilometers. So all the implementation we've been doing so far, and one antenna was sufficient to cover all the field and crops of the production. This is a central system that is going to command all the objects spread out in the field that will have the function of opening and closing the electro valves. And they will also report humidity of the soil and temperature, providing visibility of what's going on to the operation team. The key tool of our solution is on the right side, which is the Aquadon climatic trigger. So that system is going to monitor in real time the evapotranspiration. So the system is capable to see how the soil and how the plants dry out process is happening. And when the comfort zone is reaching its end, then the irrigation is launched and kick off by that system. Just below, you have graphs that allow the operation to see every areas of the crops and production, controlling the humidity and the temperature, in order for them to adjust if there's too much or not enough through the configuration panel, which is on the right side, where they can adjust by seconds the irrigation time for all the different areas. Obviously, the system allows different types of crops, so they will have the capacity to adjust irrigation depending on the type of crops you have and the depth of the plants according to their maturity. And this is what will allow us to facilitate water saving. So as a first example, we have this stadium, Numa Deli Stadium, where in 2021, in few months, we have demonstrated a water saving of 60%. And the key reason and the main key changer was the online real-time adaptation of the system according to the weather conditions. So the system is going to adjust according to the seasonality, the watering of the field, which is the area where we are creating the main reduction of water consumption. Another example is one of the largest nursery in New Caledonia, producing over 300,000 plants. Those people had a remote nursery. No one was working there during the weekends. Most of the existing irrigation system are using batteries. And when a battery is lasting on Friday, when you arrive on Monday, there is nothing left, or at least you have lost a big part of your production. And Aqualone allows two things. So first of all the objects are completely autonomous in terms of energy. There is a solar panel on the top of every object, which allow the batteries to be boosted permanently as soon as the weather is the sun is here. And also, when there is an incident, the operation team is going to receive a signal, a text message informing them where the incident and the gravity of the problem. So they can be just on call and not having to be on site to monitor what's going on. So the return on investment for this one was 6 months, which is very attractive as a solution, because you not always realize the benefit of saving water, but if you're saving your production, it makes business-wise a big difference. Another component of our solution is the centralizing data. So all the data that the system is collecting, water consumption, humidity per area, weather conditions, temperature, will allow in the coming years the operation team to leverage on their production versus watering consumption versus the weather condition, to keep on improving their consumption of water versus the payload of production they have. And as an example, so we've been contacted by the French Embassy of Kazakhstan. They are supporting the Kazakh government in a big challenge that Pearl has mentioned, which is by 2050, 40% of the water availability will disappear, and they are drastically changing their strategy in order to put water saving at the top of their strategy roadmap. And Aqualone, with this 50% plus water saving, would be a very good solution. At a scale of 150,000 hectares, you can imagine the water saving that could generate, and also providing security in terms of food self-sufficiency for the countries. So we are on the right time to provide a good solution for water sustainability. As I mentioned, the different areas where Aqualone is working is pretty much everywhere where irrigation works. So on agriculture, on the soil, off soil, in greenhouses, on golf courses, on football stadiums, or cricket stadiums. So the system has been deployed in New Caledonia, now starts to be exported in the Pacific Islands. We are starting with French Polynesia and target to expand our position in and provide our solution on the other island in the Pacific. The driver for us is going to be part of a new organization that is called Pacific Tech, where Aqualone has been integrated in that group. There is 15 tech countries, some of them working on AI, on water, on agriculture, in order to provide new solutions to the Pacific countries, and being also representing at the world level in Paris, as an example, to the Vivatech show in June 2025, coming all together to promote the technology of the Pacific. Our technology is not too new. We had the opportunity to have several awards that is giving credit of the benefits of our technology. In the bioagriculture, we've been awarded. In the irrigation show in Los Angeles, we've been awarded. We had the label of efficient solution from the Impulse Foundation, Solar Impulse Foundation, which creates some credits for our solution to be better promoted. And on the top of this, which helps very much the system to be deployed, is a very quick return on investment. In order to do that, we need to have a pluridisciplinarity team. So we have different skills within the team. Bernard Ballet being the one that has invented the solution since day one. It was initially a low-tech solution, but the quantity of water and the impact was too limited. So we've decided to put some more technology in order to bring visibility of water consumption, and AI as IoT has been the capacity for us to deploy our system and having a stronger impact on water savings. And then we're also using some software skills. So because there is lots of software to manage our data, we need also some field experts. And we have Stefan, which is an agriculture specialized in irrigation and also providing consulting services to the irrigant and agriculture. And we have also a lawyer that helps us for our patent and all the legal component of the business, and myself for the business development. In terms of best practice, my point, if this is something that you want to be involved in, first of all, you need to understand what is, for the last 24 months, your irrigation consumption and integrate the seasonality. This will help you to identify where potentially you can do some water savings. Another thing is to have a clear idea of your water consumption. What is your production loss and the reason why you have production loss. Also, where you have room for improvement in terms of fatigue, doing things that are low value. And if the IoT technology can provide you some visibility instead of you going to the field and spending lots of time controlling things, if you can have objects that do that for you, that will make your life easier. And also, we do not recognize sufficiently that energy has a big cost. Is 20 to 25% of the cost of water management. So energy-wise, how much do you pay for your irrigation is something to be considered. A very important factor is the sizing of your piping network. If it's too small, your water consumption and your efficiency is going to be reduced. So it's an infrastructure component that needs to be looked after day one, and it's a very important one. Also, filtering water is going to have an impact on the longevity of your infrastructure. They can be swapped or cleaned, and this is something that you can also have IoT that is going to send you some warnings for that. Drip line is the key component of reducing water consumption. In regards of sprinklers, the Israelis have invented that solution, growing strawberries within a desert, and that is a very, very important tool to reduce water consumption as well. And the last one would be the business opportunity to reduce your cost of production. You will see that fertigation is increasing cost of production. And if you reduce your water consumption, you are going to reduce your fertigation needs. And also you are going to reduce your illness of your crops, and obviously increase your payload if you have took in consideration all those different components. So that's it for me. If you have any questions, you're more than welcome to ask.
Thank you so much, Bertrand, for this great presentation. Does anybody have any questions Where's AI? So Jean has a question. Where's the AI in your tools?
Okay. AI is going to be using all the data that we are storing. So we centralize all the data information that are collected in all the different clients' fields. And this is going to be helpful as an example for the Kazakhstan government to consolidate irrigation water consumption. There is no tool, there is nothing today that allow the government to have visibility on overall irrigation water consumption. And because now they are going to impose in the coming years a controlled usage of irrigation. Aqualune is providing data information and will be able, with AI, to provide presented solution in a nice way, easy way, that will avoid to have to do some data management with Excel spreadsheet and database. The system is already ready to allow AI to tap on the data, consolidate information at a regional level or at a country level, or compare it in a seasoned manner in order for the government to make wise decisions, and also having them using that type of tool as soon as possible in order to consider that there is a learning curve before to be under control of irrigation water consumption at a country level.
I hope it answered that small questions. And yeah, I do think that using the climate components is also the first step of AI, where you actually have your sensors that have a direct input on your other connectors. Does anybody have another question for Bertrand? Feel free to ask. You can raise your hand or you can type it in the chat, no problem. I am trying to send you all the links that I have been sharing in my presentation. Oh. And there's many links. Maybe someone has some input that they want to share around AI and water resources. And I'm about to show you also the results from the what's the name? From the Mentimeter. Sorry, I'm just finishing this so you have everything. Tick, 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 tick.
Hi, everyone. If I may, in between.
Sure.
Thanks a lot for those presentations, Pearl and Bertrand. Really interesting. I just wanted to highlight the fact that this is mostly about sharing knowledge and experience. So the panelists of the presentations you had from both Pearl and Bertrand was to highlight a few use cases, a few things around the theme of this webinar, which is AI applied to water resources. We would be really happy and really keen to hear a bit more from you. So if you have anything to share about your own experience on how to use AI and specific use cases or whatever, please feel free to share. This is important. This is the way we do organize those webinars.
Can stop sharing for now.
A lot of links now.
Yeah, sorry, many links all at once, but at least you have them. And you will have the slides after with the links that will be active anyway, but it's just so you have them before I actually prepare all the slides and send them to you. If we don't have any questions, I actually have the answers from the Mentimeter. So let me see, share my screen here. So yes, share. So for the first question, the question was, have you already used AI for your work? We are 16 and we only have 6 answers, so I don't know where everybody else is, but many people didn't answer here. Anyway, all of you have been using AI, it seems. And the other question was, what for? And so, well, these are the answers we got. So they are all different, actually. I realized I didn't answer. So that's maybe why. I don't know if anybody would like to actually interact on this. I'm actually pretty curious about this one, institutional documents. I don't know who said it, but was it to actually help create some new laws or regulations?
Yeah, so I did. That was Jean, and the main use was about to, transform what we have as a really technical documents to some documents more adapted to institutional people. I mean, non-technical people, in order for them to take into account what has been raised from the technicals and to launch the process of a public policy.
Thanks. Thank you, Jean.
Kind of to help the endorsement of the topic and so on.
Yeah, it's okay.
Mostly about strategic documents.
I understand. It's actually a very good use. I didn't think about it that way, but it's a good one. Bertrand, you raise your hand?
Yeah, on my side, AI is very useful to synthesize information when there is lots of document to be read. It's very useful to get the essence of a big volume of information. For data management, it's also helping to create the code in order to put in different formats the data. This is really helpful, and that's the main two usage I've been doing with AI so far for work.
All right. Thank you for sharing your experience. Anybody else? I don't know. I have been trying, but yeah, I guess I have to do it one by one. Non. Permettre de parler. I guess everybody is now allowed to actually talk. See, you have anything you want to say? You just have to open your microphone and you can share. Feel free. The floor is yours. No? Nobody has nothing to say. All right. Can you actually put your camera on so we can see who's there? And I'm gonna take a picture of all of us so we can actually see how many of us are there. Normally, yeah, normally you're allowed to open up the camera, I think. Oops. Or maybe not, I don't know. No, normally everybody is allowed, so I don't know. That's weird. Oops. Nobody has nothing to say. All right, well, and if nobody has nothing to say, there was a new word that actually appeared here, which was research. And so I'm gonna stop sharing because I think here it says yes to everybody. All right, and let me see, close this.
I'd be interested in understanding better how to use AI in research.
Sure. I don't know who typed it, but if the person who typed how you used AI for research can actually share its experience. but I don't know who it was who wrote it down, so I can't.
Come on, guys, don't be shy. Any explanation would be appreciated. Just for you to know that we are leading those webinars also as Dalatera, which is a French research infrastructure. So really happy to share a bit of those uses to our colleagues, and while talking with them, sharing back to you any other uses if relevant. But we need your inputs first. We had more interactions in previous calls and in other webinars.
Yeah, we did. We did. I don't know, maybe it's because it's a big weekend tomorrow. I don't know.
Or just for French people, I guess.
Yeah, I guess. So nobody has nothing to share around AI and water. Like, you have more questions, you have some ideas that you want to share. We are here to talk about it and to try to answer your questions, even if, I mean, we're all here to learn together. Oops. All right, so let me see. I'm going to share my screen again just for the last few slides. Let me see, share my screen. It's this one, yes. So I just wanted to have a quick update to you on our partnership between the Committee of Oceania Geospatial Water Resource and the International Association on Hydrological Sciences. So we showed you the blueprint draft that we have been that we wrote a few months ago. And so just so you know, we wanted to thank you for reviewing it, and it's now it started to be shared towards the IAHS Bureau through Chris Leong, which is our common member. So just so you know, we will give you updates on this, but it's working good. So thank you for this. And our last slide is that our next Community of Oceania Geospatial Water Resource event is scheduled in 1 month, and it will be around climate change resilience, and especially around drinking water networks, drinking water and vulnerability, and water harvesting. I will share the link in the chat right now, if I manage to do it. It's right there. And I don't know if there's one last question that showed up. Where is that thing? All right, I don't have the chat anymore because I'm sharing my screen. I like this. There we go. Up. So this is the link. Thank you, everyone. I do hope we will see you again, and you will have more questions next time. And in the meantime, you all take care. Thank you so much for attending today, and thank you so much, Bertrand, for all your good experience around Aqualon, and good luck to continue this great adventure on water savings. Merci beaucoup à
Thank
tous.
you. Thanks, bye.
Merci beaucoup. Menaka.